Hello friends, welcome back to the new tutorial of the GitHub Actions. Today we are going to learn introducing the event filters and the activity types in the GitHub Actions. So those who haven't subscribed my channel yet, please do subscribe my channel, and if you like the video, please do like, share and comment on my video. Let's get started. So imagine you are a developer working on a large project with frequent code changes, okay? So you leverage GitHub Actions to automate the task like building, testing and deploying your code. However, not every push or the pull request requires the entire workflow to run. Okay, so this is where event filters and the activity types come into refine your workflows to execute, saving resources, focuses on what truly matters. Okay, so before diving into the filters and the types, let's revisit the different events that can trigger a GitHub action workflow. That is a push, pull request, and the issues and the schedule and the workflow dispatch. So these are the events which we have already discussed, right? So whenever the someone is pushes the code, the push event will trigger. When this event will fires various actions on the pull request like creation, opening, editing, reviewing or merging. That is a pull request. Issues, so this event reacts to the changes in issues such as creation, editing, labeling, assigning or closing. Then we have a schedule. This allows the workflows to run recurring schedule like daily, weekly or monthly. Okay, then we have a workflows dispatch. This lets you manually trigger the workflow or directly or run directly from the GitHub Actions interface. Okay, next we have the event filters adding specificity. While events provide the basic trigger mechanism, right? So events basically provide the trigger mechanism. Event filters allow you to define additional conditions that must be met for your workflow to run. Think of it as adding a layer of control on the top of the event itself, right? So first of all, we have to specify the event. You start defining the event that triggers the workflow like push. Okay, so add filters. Next, you can add the filters within the event definition using a colon followed by the your filter criteria. Filters are typically key value pairs separated by the commas. So here you can see that we have a paths. So example with the push events. So this is a push which branches. So here you can see that we have mentioned and paths. So there is a push to the main branches. Okay, so the main branches and the push includes the changes to the files ending with the .j. So only it accepts the, here we can see that we have add of extra layer, that is paths. So the push includes the changes to the files ending with the js, so it only accepts the changes which has the js files and they have the changes. Okay, so next we have the common push event filters. So branches. Okay, so here you can see the branches we have a tags, we have a paths. Okay, so branches specify a list of branches to trigger the workflow. So when workflow will trigger only when somebody is pushing the code to the main branch, master branch. So you can add extra layer. Then we have a tags trigger on the tag creation or deletion like v1 0 version. So these are the tags. Then we have a paths, define the file paths or the patterns that must be matched, that must be changed to trigger. Example, py file, readme file or js file. When you want to trigger the workflow, only specific files are modified. Okay, so when it will trigger, when specific files are modified, then it will trigger, right? So you can mention like this. Then we have a activity types. So granular control within the event, certain events like pull request, issue, comment and have multiple activity types associated with them. So these types provide even final control when your workflow runs. So specify the events. So define the event that triggers the workflow, that is pull request. So use types, append dot types to the event and specify the desired activity within the square brackets. So how it is, so this is the activity that is types. So here you can mention that whether it's to be open, synchronize, reopen and the close. So this configuration triggers the workflow only when the pull request is opened, means like this. So here you can mention the types, right? So common pull request activity types, what are, that is open. So workflow runs when the pull request is created, closed when the request pull request is closed, Edited when the pull request is edited. Labeled, workflow runs when a specific label is added to a pull request. Unlabeled, workflow runs when a specific label is removed from the pull request. Synchronized, workflow runs when a pull request is updated from the base branch. Reviewed, workflow runs when a pull request receives a review from a collaborator. Review request, workflow runs when a pull request author requests a review from the collaborators. Then we have a merged. Workflow runs when a pull request is merged into the base branch. So these are the common pull request activities that you can use. Okay. Then benefits of using the filters and the activities. Why we are using? So first of one, by filtering events, you avoid unnecessary workflow runs, saving resources like compute time, potential reducing cost associated with the running actions, and this will especially beneficial for the large code bases with frequent changes. Okay. Enhanced specificity. Activity types allow you to target specific actions within an event and leading to the more precise workflow execution. You can focus on the most critical changes that require automated process. Okay, so this is that one. So any doubt, any query in that, do let me know in the comment section. Next video, we are going to learn controlling your workflows, canceling or skipping your GitHub actions. So thank you so much for watching this video and don't forget to like, share and comment on my video. Have a nice day.